Well, what else could we possibly do? I mean, we looked at the parabola, we put it in the vertex form. We looked at it, we graphed, right? What else? What else is there to graphing parabolas? Aha! Now that we're dealing with conic sections, we're not restricted to functions. Obviously, in the first section, we did circles, right? Circles are not functions. They don't pass the vertical line test. And so here, parabolas, they don't have to pass the vertical line test either. When we studied them before, they did, because we were talking about quadratic functions. But we're not going to limit ourselves to that anymore. So here is the general form for a sideways parabola. They might open to the left or to the right. So what do? Well, you see it, x equals ay squared plus by plus c. We just switched the x and the y. So where before it was y equals, and ax squared plus bx plus c, switch the x and the y, and now it will open to the left and to the right. Let's look at the standard form for a sideways parabola. Well, it's really identical to what we had before, but now we've switched the x and the y. And you notice the h and the k switch as well. We always think of h going with x and k going with y. So now it's x minus h equals a y minus k squared. So if we just look at the points, the vertex is still hk. The h goes with the x, the k goes with the y. And how does it open? Well, it's still all about that value a, but this time if a is positive, that means it opens in the positive x direction. It opens to the right. It's opening up towards the positive values of x. If a is negative, it opens towards the negative values of x, to the left. It's like that. Again, we're not constrained with functions anymore. Okay, let's get to an example. Here's part B. Same instructions as earlier. We're going to put this in the standard form and then graph. So we're given the general form x equals negative 3y squared minus 6y minus 1. Well, the steps are really exactly the same to the parabola that might open up or down. We're going to begin by adding that 1 to the other side, grouping together the y's, like so. Eventually, this will become the h, and we're going to complete the square right here. Now, if you think back to when we first learned about completing the square, you might remember you're never allowed to have a number in front of your square. So we can't complete the square as it is. We've got this negative 3 that we have to deal with. When we did completing the square in the past, we said, okay, if I can't have a negative 3, let's just divide everything, both sides, by negative 3. And then that would leave me with y squared here, and I could proceed. Well, we could do that, but just the nature of this thing, and because we don't just have a single number on this side, we've got these x's. In order to get to the standard form of this parabola, we actually don't want to divide by negative 3, but we want to do something that really has the same effect. We're going to factor that number. Okay, so it's going to look like this. Let me kind of make a note here. Factor negative 3 on the right side. Okay, so we don't want it there. We can't have it when we complete the square. We don't want to divide it either, so we're going to find this kind of other thing that's going to help us, which will have the same effect as dividing. Factor it out, leaving you with parentheses y squared plus 2y. Don't forget to factor that negative in the middle when you take the negative 3. Okay? And now it's like we've grouped the y's, y squared plus 2y. We can complete the square here. Okay? So think, all right, complete the square on y squared plus 2y. Well, I see a 2, so divide it in half, square it, no problem. If I divide that in half and square it, that's going to be a 1. So I'm going to add 1, y squared plus 2y plus 1. I still have the parentheses. I still have the negative 3. Okay, now it's time to balance out that 1 on the left side. Wait a second, though. You see, how is this? Why is it a minus 3? Okay, we added 1 here, but because we added the 1 inside the parentheses, we did not actually add 1 to the right side. In adding 1 inside the parentheses, remember this negative 3 would multiply by it, we actually subtracted 3 on the right side. Let me say that again. When we added 1 here inside the parentheses, the effect was we actually subtracted 3 from the right side because that 3 would distribute to it. So if we subtracted 3 here on the right side, we also need to subtract 3 on the left. So when you think about how to balance, if it's inside a set of parentheses, remember that number in front is always going to multiply by this number. That's what you got to do to the other side to keep it all equivalent. Okay, hopefully that makes sense. If not, hey, come to the live meeting. We can do examples together. We can talk through it. Again, one more time, because this just really gets people. Whatever you add, if it's inside parentheses, always multiply by this number. That's what goes over here. It happened to be minus 3 for us. All right, now let's clean it up. We're only a step away. We'll simplify here. We will factor this. Since we've done this now many times already, let's just go for it. Hey, we've got x minus 2. On this side, we've got negative 3, y plus 1 quantity squared, and that is our standard form. Okay, that's pretty cool. Now, we're going to move towards graphing this. So let's begin with how this parabola opens. All right, well, A is always that number right there. It's negative 3. It's what we factored out. Hey, it's a negative, and this is a sideways parabola, so this is going to open to the left. We're opening in the negative x direction. Okay. All right, next up is the vertex. Well, this doesn't take any work once we have the standard form or the vertex form. All right, the x coordinate, well, look at the x. It's going to be positive 2. For the y coordinate, look to the y. It's always the reverse of what you see, so the y coordinate is negative 1. All right, so far so good. Step 3, the y-intercepts. Okay, so we're going to set, let's see if we can get all this on the screen just for a moment. We're going to set x equal to 0. So we're going to set x equal to 0. Okay. 0 minus 2, negative 3, y plus 1 quantity squared. Well, the 0 minus 2 just gives you negative 2. We would like to isolate the y, so we need to begin by dividing by negative 3. Cancel that out. That would give us positive 2/3 equals y plus 1 squared. Then we can square root. The square root cancels the square here. Square root, don't forget your plus or minus. Very important, don't forget that plus minus here. Okay. Now, because we have the plus minus, we need to think of it as two separate equations. And I just went ahead and put the y plus 1 on the left. Seemed a bit more natural. Y plus 1 equals square root 2/3. Y plus 1 equals negative square root 2/3. And of course, we need to subtract 1. Both negative 1 plus 2/3, square root 2/3, negative 1 minus square root 2/3. Let's bring that up a little bit. Okay. What are these numbers? So we're going to graph this in a moment. And to be honest, I have no idea where these numbers are. So grab a calculator at this point. We need to find the decimal versions of these two y-intercepts. If you find this one, you should get negative 0.2. This one turns out to be negative 1.8. Okay, so we will graph these in just one decimal place. If you're going to graph, one decimal place is going to be plenty accurate enough for you to eyeball it. We do have one more step. Step 4 is to find the x-intercepts. Turns out that's the easier one in this case when it's sideways. So we're going to set y equal to 0. No problem. X minus 2 equals negative 3. 0 plus 1 squared. And we'll solve for x. All right, well, that's going to be 1 squared is 1. So that right side just is negative 3. Add the 2. And we've got our x-intercept right there. Okay. I'm going to grab my graph paper at this point. We found the vertex to be the point 2, -1, 2, -1. We found the y-intercepts, so here on the y-axis, to be negative 1.8 down there, and negative 0.2 right there. Okay, it's going to open up to the left, right? There's our vertex, opens left, that makes sense. And we found the x-intercept on the x-axis to be -1 here. We can get one more point if you imagine the axis of symmetry going, this time the axis is going horizontally through the center of the parabola, through the vertex. So we can use this symmetrical point from our x-intercept right there. So it's all nice and symmetrical. Okay, that's enough to graph. And the further you get away, the more you have to just kind of wing it, but something like that. It's going to be pretty good. That is curved. That is not a sharp point right there. Hey, that does it for parabolas. Good luck in the homework.